Hi everybody, Mr. Rubo here. Today we're going to go over pages 1 and 2 in chapter 10. And we're starting circles. So there'll be some properties here that we'll talk about. But probably the biggest thing is making sure you just draw things correctly. Because once you draw them, you'll see, you'll be able to use some properties of circles and um, get the answers. So these first 5 questions, again, if they don't give you a drawing, draw it out. And so yeah, here we have 2 circles intersect and have a common chord of 30 inches. So little vocabulary here. Chord is any segment that goes from one end of the circle to the other. So its endpoints are on the circle. So saying it as a common chord means it's shared between the two. So we have that there, and that's our chord there in black. So this is 30 inches. Then we have the centers are 28 inches apart. So this guy connecting the centers is 28 inches. And then it tells us the radius of the first circle is 17. And it wants us to find the radius of the second circle. So, this is going back a little bit to last semester. Well, if you recall, if you have things that are equidistant to the endpoints of a segment, they form the perpendicular bisector. Well, this center, both these centers are equidistant to both the endpoints because they're the same radii, right? So if I were to draw this in, the line connecting the connecting the centers is the perpendicular bisector of that common chord, which means this is 15. Okay, once you know that that's 15, another little property that comes up, or another part of that property is it's a perpendicular bisector. So there's a right angle. So we get a bunch of right triangles here, and we can use Pythagorean theorem, or you could just use your Pythagorean triples. So you actually figure out, okay, this part of it is 8, which means this part is 20. And then you have 2015 as this side, right? And so then your radius would be 25. And all Pythagorean triples, so not a lot of work that needed to be done. All right. So now we go to the next question. This one they actually give us a drawing, which is helpful. So it says circle A, CD is 12, so that is the outside portion. And by the way, B here should just be on the circle. It's just got printed off weird. BC is 16. AD is 25. Okay. So what we end up doing here, kind of similar to our German problems, is we're going to go ahead and draw in a radii. And I'm going to go ahead and draw in this line here that goes to the midpoint. Basically what I'm doing here and kind of doing a little shortcut of it is if you were to draw in both radii, so I'll kind of show this out completely, we have an isosceles triangle because the two radii are congruent. Drop the median, which is also an altitude, and it's because it's a median, this is 8. Okay. Um, so now we are trying to find DE, right? So I'm trying to find that. Well, if we look, we actually end up having enough information. If I look at this side here, so I'll kind of redraw this. The big thing to A, and then draw. There we go. I have a big right triangle, right? So 8 and 12 is 20. That's 25, which means this is 15 based on our Pythagorean theorem or Pythagorean triples. So I now know this is 15, this little length here. And because I know that's 15, I have 8, 15, and then the radius is 17. And then once you know the radius is 17, AC is a radius, but so is AE, so that's 17. So now all I have to do is 25 minus 17. And when you do that subtraction, you get 8. Okay. All right. Then, again, now the next three are all ones where we got to make sure we draw the picture correctly. Once we draw the picture, it's a lot of radii work. All right, so it says find the distance from the center of the circle to a chord 24 inches long. If the diameter of the chord is diameter of the circle is 26 inches. So we have some chord. Oops, not a little too far there. It's 24 inches. We got the center, and they tell us the diameter is 26, which means our radius is 13, right? Well, we want to find the distance from the center to this chord. So whenever they say distance from a point to a chord or point to a segment, that's the perpendicular distance. So we actually form a right angle, and very similar to the last problem, this segment that goes from the center to the chord and forms a right angle is actually the perpendicular bisector. So that's 12, and we have 12 and 13, which means the distance, which is what I'm looking for, is 5. All right, number 4. Two circles intersect and have a common chord. Very similar to the one we did earlier. So we got one circle, two circles, common chord. The radii of the circles are 13 and 15. And again, it does not matter which one you call 13, which one you call 15. And then the distance between their centers is 14. So that distance is 14. And we want to find the length of the common chord. So what we're going to do here is we're going to do just a little bit of like a little system here. So I'm going to call this y, and I'm going to call this part of the triangle x. So then that means this side would be, like the other side would be 14 minus x. So basically I have two triangles. And if I do Pythagorean theorem here, I would get x squared plus y squared equals 13 squared. And then the other triangle, I would get 14 minus x squared plus y squared equals 15 squared. And if I end up solving these for y, like I could solve this one for y squared pretty easily. So, right, 13 squared minus x squared. I'm just going to take this and substitute it in for y squared. And now I get a quadratic with only x's. Okay. And, go ahead, take your time, solve this. And I'll let you know, you should end up getting x equals 5 when you solve it. Because actually, even though it starts off a quadratic, the x squared terms actually will cancel each other out. Because one ends up being positive, one ends up being negative. So then you get that x is 5, and then once you know that x is 5, we'll look at the triangle on the left. You can then say, oh, well, this triangle is a 5, 12, 13. But we want the whole thing of the chord. Well, that's half of it, so your actual answer is 24. Okay. All right, number 5. We look at this. A circle has a diameter of 30. So diameter of 30. Two radii are drawn such that they form a 30-degree central angle. So 30 degrees here. Radii, which means half of the diameter. Find the area of the triangle that's formed by connecting the two endpoints. So we have this. We want to find the area of, my pen doesn't want to work. There we go. This triangle here. So the key with this is right now this is not a right triangle, but if I'm going to redraw it over here. If I take this, say, okay, that's 30 degrees, this is 15 and 15, I can actually drop the altitude, because that's what I need, the base and the height. Well, if I call 15 the base, I can then figure this out. So if this is a 30-degree, now we have a right triangle with a 30-degree angle. We then know it goes in x root 3, 2x, which means 15 is equal to 2x, which means x is 15 over 2. And then we have the height. So now all we have to do is 1/2 base times height, which means 1/2 15 times 15 over 2, because that's our height, which is 225/4, which also you could write as a decimal in this case because it's a nice decimal. So either one of those two answers is fine. All right. On the next page, there is this proof of why, if you know that the distance from the center to the chord is the same, because that's basically what OB and OE are, the distance from the center to the chord, you could prove that AC and DF, those two chords, are the same. I'm going to skip the proof. If you want to see it, it is on Canvas, so feel free to go ahead and look at that. But I do want to go to this problem down here because this is our another example of a good problem. So two concentric circles, in other words, they share a center, almost like a dartboard, if you will. Right, dartboards are concentric circles. We have a radius of 12 and a radius of 15. So obviously the circle on the inside has the 12 and the radius on the outside is 15. And they say a chord is drawn in the outer circle that is tangent to the inner circle. So tangent, when we're talking circles, means it hits the circle once. And they want us to find the length of this chord. So the way we do this is draw in our radii. So I'm going to draw in one radii that goes all the way to the outside circle, which we know is 15. And then I'm going to draw a second radii of the inner circle. And one of the properties of tangent lines is if you draw the radius to the tangent line, it forms a right angle. And that's really nice because now we have 12 and 15, which means this side here is 9. And just for the sake of it, you can actually make a congruent triangle by drawing in this radii. So if that's 9, this is 9. So our answer is 18. Okay. So that's it for today's notes. Thanks for watching. Have a good day.